Yes. All right, looking at our homework, we're going to review it from yesterday before we begin our next lesson. So looking at the guided practice 1 through 4, it said write each ratio 3 ways, but I also asked you to create tables for each problem so we could understand our what? We could understand what it's asking for. Is it a fraction? Is it a ratio? How do they want it? Is it asking for the missing part? So looking at 1, there are 5 cats for every 4 dogs at the animal shelter. What is the ratio of dogs to cats? Let's put down what we know. Cats, there's what? 5. You're good. And then for every is another word for 2. For every is another word for what?
2.
Okay. So my other category is going to be dogs. How many? 4. And then why do I have another category? That's my total, because these were my parts. So I have a part, and a whole, or we like to call it total. So part, whole, part, total. What's my total going to be? 9. Now, when you look at the question, did it ask anything about the total? No, but later on it could be a part 2 to this question, and you could automatically know what your total is based off of the table that you created earlier. Get it? Got it? Okay, so what's dogs to cats? And order matters, okay? So what's dogs to cats? 4, 2, 5. And I am going to tell you, they tried to trick you because in the beginning, what did they start off with? 5. So correct your work if you need to. You do not have to use a red pen today because you're just correcting your homework. If you want to use a red pen, you can. Get it? Got it? Now, did anybody get tripped up on that problem? Did anybody put 5 to 4? You're still what? Cool. Don't assume that it's going to say, oh, what's cat to dogs? They want to trick you. Okay, and this was just a level 2 because did they tell you everything you needed to know? Yep, they just tried to trick you at the end. All right, number 2. In band, there are 3 woodwinds for every 1 percussion player. What is the ratio of woodwinds to percussion players? Okay, so I'm going to put a W for woodwinds. And what was that? 3. And then I'm going to put a P for percussion. And what is that? And then my total amount of players is going to be 4. Okay? And again, it asks woodwinds to percussion. And that would be 3, 2, 1. Now, does anybody want to point out something that I forgot to do? What should I be doing? The 2 other steps, okay, 2 other ways to write, correct? Okay, did anybody forget that like me? Okay, good. So what do I need to come back and do to 4 to 5? Make it a fraction. What's the other way? As a word. Get it? Got it? Also, on number 2, I just wrote it as a ratio with that colon, but now I need to do 3 over 1 and then 3, 2, 1. So that's something that I noticed that some of us, when I walked around, that we forgot to write it all the ways. You did the table, but we forgot to write it all the what? Ways. And you're still cool, but pay attention to make sure if it asks for all 3 ways, then you do all 3 ways. Get it? Got it? And let's review real quick. So mirror words. Ratios. Can be written. 3 ways. 3 ways. My finger isn't working. Anyway, so it can be written 3 ways. 3 ways. As a colon. As a fraction. And with the word to. Mirrors off. So I did that with the word to because we're actually talking about the word to, not TWO. We're talking about TO. Get it? Got it? All right. Now, looking at 3. In Kelsey's pencil case, she has 2 highlighters for every 7 pencils. What is the ratio of pencils to highlighters? So here we go again. We got some highlighters. How many is it?
2.
You're still cool. 2. And then we got some pencils. And what is it?
7.
And then it wants pencils 2, highlighters. So that would be 7 to 2. But what could they have asked us about? Our total. And what would our total have been? 9. So don't forget when you're setting up your table to include a total. Now, write it as a fraction and then write it with the word. And that was mainly our lesson today. I'm hoping on this next one they ask for something that is not listed in the beginning. So here we go. In the bag there are 19 green marbles for every 11 blue marbles. What is the ratio of green to total? Well, I know green there is what? 19. And I know for blue there is. And then my total would be 30. And what did it ask for? Green to total. Did it tell us the total in the beginning? We had to understand that if you have a part, it makes a total. It makes, what's another word for total? Whole. Okay, so my green is going to be 19, and then my total will be 30. And then I need to write it as a fraction, and then with the word 2. So that was our homework. If you are still struggling with this, then that extra practice below, numbers, so yeah, 5 through 8 is extra what? Practice. Same thing with the other things that we did not do in that packet would be great extra practice. If you do not have anybody at home that can check it, if you don't have a grown-up that can check it at home, I'm happy to help you in the mornings when you come in, okay? So you'll just have to be responsible to be able to ask for help, okay, in the mornings. But make sure you have those extra practice done so I can help you. Does that make sense? All right, so moving on to lesson 3 and 4. We are still working with ratios today. We are still working with ratios. So we're going to get this distributed out. While they're giving that to y'all, you can put those other papers back in your binder in that sheet protector. Okay, so rule number 1 is to follow directions immediately. So quickly do that while I get everything else ready for us today. Rid of this work. So while we are waiting for our stuff to be put away, I do want to remind you that tomorrow, what test do you have? Tomorrow's Thursday. What's it going to be tomorrow? Okay, you do have Word, Be Wise, and Reading. I agree. But what else do you have? You will have your STAR test. Got it? Make sure tonight you are well rested for in the morning. We will take our STAR test after Miss Reno's crew. So we will have a short lesson in the morning before you take your STAR test. Got it? And then you'll go take your STAR test, and then you'll be back in Miss Reno's room at the end of the day like normal. Got it? Okay, so I just wanted to give you a heads up of what's happening tomorrow. Okay? And then don't forget again that what's due Friday So please make sure you're staying on top of that, okay? So let's get started. We are on lesson 3, and I'm just going to read it, and then we'll do our gestures with this. Remember, with a capital letter, we do our tall arms. If we say understanding, we point to our brain. If we have something underlined, like equivalent ratios, we underline it. And then when we have a period, we are going to do just 1 second, because a period means to stop. Get it? Got it? But before we begin, there is something that needs to be fixed. Tape diagrams are a great strategy, but what did I tell you is going to be your very best friend at the beginning of this lesson? What's going to be your very best friend?
Tables.
What kind of tables? Ratio tables. So instead of saying tape diagram, we're still going to be working with ratio what? Tables. Get it? Got it? Good. Okay, so when I'm looking at this, here we go. We're going to start it together, and we're going to say it slow. 1, 2, 3. I can develop an understanding of equivalent ratios by using ratio tables. Perfect, good job. Okay, so now let's get started. So we're on this paper. Does everybody have this paper? All right. So equivalent ratios are obviously what? Ratios that describe the same. Think about fractions. Equivalent fractions are fractions that describe the same, okay, meaning. Let's get another word going. That's a good one. If it's equivalent, that means it's what? Equal to the same amount, okay? Amount would be a great word for 3rd, 4th grade, and even 5th. But I also want to add in for a 5th and 6th grade, 7th grade word. We're also going to write value. Because remember, value, if we think about value with some money, with some moolah, okay, that's what value means. You think about money with it. So if I say, how much is a penny worth? What is the value of a penny? You're going to tell me what? 1 cent, okay? So equivalent ratios are ratios that describe the same amount and value. Thumbs up when you have that written. All right, my next one, you can find equivalent ratios by doing 2 different operations to the numerator and the denominator by using the same number. What's those 2 different operations you can use to create equivalent ratios? I could be saying equivalent fractions. What do you do to that numerator and that denominator to make something equal? We learned last week that it was called simplifying fractions. And what did you do to simplify? Divide. Well, yesterday we mentioned creating equivalent with the tables. What did we do to those numbers as we were going down the tables? We multiplied, and we have already created equivalent ratios, okay? And you will hear me say equivalent fractions. You will hear me say equivalent ratios. But remember, a ratio is a fraction. The value of a ratio is a fraction. Okay, so if you yell out in a minute, fraction, you are still what? Correct. But I might ask, okay, what's the 6th grade word for fraction? Ratios. Get it? Got it? So you can find equivalent ratios by multiplying. I do. We do. I do. So you can find equivalent ratios by multiplying or dividing each quantity in a ratio by the same number. Okay? So you learned that in 4th and 5th grade. But instead of them saying equivalent ratios, they also said equivalent what? Fractions. Get it? Got it? Now it says write 2 equivalent ratios for each ratio below. When in doubt, table it. Your table is going to be your very best friend to help you create equivalent ratios. Okay? So I'm going to create my table. Do we have the names of the categories here? No, we have the numbers. So on this instant, we don't have names. So do I know what's my part and my part and my whole? No, I only know the numbers. So when I create this table, I'm just going to make it a T because I do not know my categories. I do not know my what? Okay, so my first ratio I'm going to have written is 3 to 20. So the only difference about this table from yesterday is we don't know if it's a part, and a whole. Get it? Got it? But we're still going to create equivalent ratios. So it needs 2 more. Are you ready? What do I need to do to the numerator and the denominator? What do y'all want to do? Multiply it by 2. You could do 10, you could do 100, you could do whatever number to infinity n, but I'm asking you to keep it small because it makes it easier. Okay, and remember we use a dot in 6th grade to represent multiplication. 3 times 2 is 6. 20 times 2 is 40. Okay, I created another ratio, 6 to 40. How many did it ask for? 2. It asked for 2 of them. So here we go. 3 times 3. And then, 9. And if I do it to my numerator, if I do it to my left side, I have to do it to my denominator, which is the right side. So 20 times 3, 60. And I created my 2 equivalent ratios. Yes. And what will it be? 9 to 60. Did I answer everything for that section? Yes. Okay. So when I'm looking at this, we multiplied both times. On this one, could we simplify by 3? Simplify is to divide. 3 divided by 3 would have been? 20. But 20 divided by 3, if you put that in your calculator, 20 divided by 3, if you put that in your calculator, I'm just making sure I don't need to grab calculators. Okay, do you get a whole number? No. So could we simplify this fraction? Could we simplify this ratio? No, the only thing that we could have done to this ratio was multiply to create the equivalence. Okay? So when I'm looking at my next one, think about 5 to 6 as a fraction. Could we simplify 5 to 6? No. But what could we do to make equivalency? Multiply it. So let's do it again. When in doubt? Good. So 5 to 6. And create your next ones. If you want to multiply by 10 and 100 or your own number, go right ahead. But I'm going to use smaller what? Numbers. Okay, so here we go. Multiply by 2, and to my numerator, my denominator, if I do it to one side, I have to do it to the other. 5 times 2 is 10. 6 times 2 is 12. And then I'm going to do 3 again. You could do 4. You could do 5, 10, 100, infinity n. 5 times 3 is going to be... You're still cool. I promise I'm going to make mistakes. Look, that's why I'm asking. Like, I was like, it probably is 18. But it's good. You're still cool, okay? 5 times 3 is? Now, 6 times 3 is?
18.
There you go, girl. Alright, here we go. So, 5 to 6 was my first ratio. My next ratio is 10 to 12. What's another one? Would 50 to 60 be one? Why, what would I multiply by? 10. Okay, y'all so smart. Look at y'all go. Alright, look at my next one. Think about it. Could we simplify it? Yeah, we could. Yeah, we could. We could simplify it. Look at 5 to 15. What's in the ones place of both numbers? What can we divide by? When in doubt? Instead of multiplying here, let's what? Divide. So 5 divided by 5 is 1. 15 divided by 5 is 3. Is that still correct? Is that still a ratio?
Yes, ma'am.
But it's simplified all the way down. Okay? So you can multiply them, you can divide them. I'm going to go back up to the top and let's multiply it, because 1/3 is simplified all the way down. 1 to 3 is simplified all the way down. So 5 times, what do y'all want to pick? 2. Okay, so 5 times 2 is 10. 15 times 2 is 30. Did we understand why I divided and then I multiplied? You've seen it on Zern where it divided one time and then the next row it wanted you to what? Multiply. Okay, it did this to you on Zern. Okay, so here we go. My ratios are 1 to 3 and 10 to 30. I am writing these with colons because I believe colons are fast and efficient for ratios. Could I be writing all of these as fractions? Yes, that is still a
Ratio.
yeah. All right, so I think we're good on these. I think we're what? I do want to do just this last one. What's in the ones place of both of them? 0, right? You can divide it by 5 or you can divide it by 10. Okay? So if I put 10 to 20 and I divide it by, ooh, I could divide by 5. What am I going to get for my row? 10 divided by 5 is? 20 divided by 5 is? Now go back up to the top. Instead of dividing by 5, we can divide by 10. So 20 divided by 10 is 2, and 10 divided by 10 is 1. So my equivalent ratios are 1 to 2 and 2 to what? 4. Okay, so there, did we even have to multiply? We could have, right? Yeah, we could have 20 to 40, 50 to 100. We could have gotten those, because why am I saying those? 8 to 16. What did it simplify down to? 1 to 2. And that's 1/2. And if we start thinking about what can be halves, 500 out of 1,000, 3 out of, 4 out of, 6 out of, okay? So we could have had multiple here, okay? And I know a lot of us, when we get to the halves, you're like, do I have to do a table? Go ahead and get it in your head. When in doubt. Now at the bottom, I know you can't see it, but your number 3, if you look at the bottom of my screen, it says you can solve real life problems using, what is our title of our lesson? Equivalent. Ooh, this one would be a fun one to do speller size. Equivalent. We might do equivalent tomorrow for speller size. That would be a fun one. Yeah. Yeah, positivity. All right. So we are going to move on. You're at the bottom of your paper on that guided practice. Do you see the guided practice at the bottom? Okay, that's where you'll be writing. I know on mine, my screen, it's up at the top. But you're at the bottom of your what? Paper. It says Carly is mixing paint. The ratio of red to white paint is 2 to 1. If Carly uses 6 parts red paint, how much white paint does she need? This is when tables are your very best, and you're going to take one sentence at a time. So I want you to put your pencil down, and I want you to give me hands and eyes, laser. So hands, eyes. Okay? So I want you to pay attention here. We know Carly is mixing pink paint. Can we do anything with that sentence? No, but we know she's mixing pink paint. Okay? The ratio of red to white is 2 to, that's my ratio in my table. I'm going to have red. I want y'all to watch. Don't write. I want you to watch. I'm going to have red, and then I'm going to have white. What was red? What was white? What did red and white make if you mix it? Pink. You could put a P here. Don't write this. Just watch. I want you to learn. Okay? Red was 2. White was 1. Our total is going to be 3. And our total is representing what color? Pink. Okay? Does everybody understand where I got that from? Okay. So all I did was read sentence number 1 and number 2. Now write that down. Now write that down. Do not do anything else. Now write that down. Did it? Got it? So we have the red, that was 2. We have the white, that was 1. And our total, which is representing pink paint, is 3. Does everybody understand where that came from? When we get to the next sentence, this is leveling up. Okay? It's a level 2 problem. It says, if Carly uses 6 parts red paint. You're like, she's using 2 parts red paint. Ratios are not exact. You can create equivalent what? Ratios. Okay? We have to find the missing value, and you did that all the time with fractions, and you had to do something called cross multiplication. Okay? You're doing the same thing here. Okay? But watch. Here we go. If Carly has 6 parts red what? I need to create another row. And where do you think I'm going to put 6 between? I'm going to put it under what? Red. Once you have that written, give me a thumbs up. Once you have that written, give me a thumbs up. Now, you can put your thumbs down. Does everybody understand why I put the 6 there? Because it said on that next sentence that it was 6 parts red paint. So I needed to put the 6 also under red. Now, I have to fill in the rest of these missing values. When we create equivalent ratios, you either multiply or divide by the same number. They are going from a little number to a big number. From little to big, you multiply. What did they multiply by? 3. 2 times 3 is 6. If I use 3 here, I have to use 3 to every single one of them. That is called your constant number. You constantly use 3 and you're multiplying by it in this sense. Sometimes you might divide. It matters on if you're going from a small to a big number, you multiply. If you go from a big to a small number, you divide. Okay, I'm going to say it one more time. If you go from a small to a big number, you multiply. But if we went big to small, what would we do? Divide. But what does not change? The 3, right? The operation would just change, okay? Constant number is 3. But what's happening to 3 here? We are multiplying. We are what? And if I do it to one column, and sometimes it might be rows, it matters on how they list your table. If I do it to one column, I have to do it to every column. And that's like saying if I do it to my numerator, I have to do it to my, but now we also have a total. So if I do it to my numerator, if I do it to my denominator, I also have to do it to my total. Get it? Got it? So now 2 times 3 is 6. 1 times 3 is 3. 3 times 3 is 9. Fill that in and give me a thumbs up. Have I completed all of my sentences? Have I read all of my sentences? The only sentences I have read is Carly is mixing pink paint. The ratio of red to white is 2 to 1. She uses 6 parts red paint. What do I have left to read? How much white paint does she need? Look back at your very best friend. When in doubt, table it out. What was your very best friend? The table, right? We're looking at it. What category am I looking for? Only white. What's my answer going to be? 3. Because when she had 6 parts red, she needed 3 parts white. Was that hard? No. But we have to get to the practice of being able to set up a table to help us solve this. Okay? All right. So I think we're good at making your own tables. Let's just practice number 1 real quick. Get it? Got it? Do I know any categories here? Nope. Let's just make some equivalent ratios. Now let's just stick to multiplying. 6 times 2 is
12.
16 times 2 is
32.
Am I done yet? Nope. All right. We could do 5, 10. We could do whatever here, but let's just stick with small numbers. 6 times 3 is 18. 16 times 3 is 48. Good. So do we remember how to do this? Okay. So real quick before I go to the next slide, homework will be numbers 2 through what? 4. Okay. Now I want you to go to 5 through 8. Now I'm going to do a few problems with you. Get it? Got it?
Good.
All right. Does everybody have homework written down?
Yes, ma'am.
We're going to add something to it in a minute. Okay?
Yes, ma'am.
So looking at 5, automatically I see a ratio story. And I'm automatically going to know I need to use a ratio table. Okay? The ratio of dogs to cats at the animal shelter is 4 to 5. If there are 20 cats, how many dogs are there? How many of you went, take one sentence at a time. You know you need to create a ratio table. Dogs to cats. D and C. Fast and efficient, abbreviate. So D and C. Dogs and cats. If there's dogs and cats, now we're going to have a total amount of animals. So put a T. What did they say dogs was going to be? Or, what did they say the cats would be?
5.
And what's my total? Okay, thumbs up once you have that written. And I wrote that just from the first sentence. I wrote that just from the what sentence? First. Then on that next sentence, it goes, if there are 20 cats, they obviously are wanting you to create an equivalent ratio. Oh, okay. So if there's 20 cats, where am I going to go put 20? Under what number? Cats under 5, right? How many dogs are there? Well, we don't know yet. We got to use this table to find the word. Look at the one they have listed. We got 5 and 20. That's what we know. How did they go from 5 to 20, from little to big? Multiply by 4. And you have your calculator. If you're not good at your facts, all you have to go is 20 divided by 5 and you get 4. Now you know what you multiply by, okay? So 5 times 4 is 20. Am I done?
No, ma'am.
That was my constant. What was my constant number? 4. What did we do it for? We multiplied. Now I need to do it to every other part of my table. 4 times 4 is 16. 9 times 4 is 36. Now can I answer, how many dogs are there? And what would it be?
16.
16, and we can put dogs. The reason why I'm going ahead and getting you a total every single time is, what if the last question is, what's the total amount of animals? You would be able to already tell me, what's the total amount of animals for the new ratio? 36. I know they didn't ask for the total, but you're going to go ahead and get in the routine of doing a table, a ratio table with the total, so you don't get overwhelmed when they finally ask you that. Okay? All right. So, I'm going to do one more on 7 with you, and we're going to just keep on practicing these types of problems. I just don't want you to have too much for homework today, okay? So I'm going to do 7 with you. The ratio of girls to boys in the grade is 6 to 8. Put that on the table. The ratio of girls to boys in the grade is 6 to what? 8. So we're going to have a category for girls, we're going to have a category for boys, and then we'll have a... Okay, so fill in what you know from that first sentence. Fill in what you know from that first sentence. So what do we know for girls? 6. What do we know for boys?
8.
And what will my total be? Okay, do we all understand that?
Yes,
Am I done with my problem?
No, ma'am.
Oh. If there are 120 girls, automatically I'm like, oh, I need to go put that on my table. What do I put 120 under? Girls. It asks how many boys are there. But let's go ahead and fill in what we don't know. How did they go from a little to a big number? You multiply. Do we know what they multiplied? Some of you might know automatically. But if you don't know, Put it in your calculator. 120 divided by 6. And you get 20. If you are not confident in that answer, check it. 6 times 20 is 120. Does everybody understand? Once these numbers get bigger, how do you find out what they multiply by? You gotta divide. If you can't figure it out, you'll have to divide those numbers. Get it? Got it? If I do it to one column, one day we might be going rows, but if I do it to one column, I have to do it to all of them, right? The other. So 8 times 20 is 160. 14 times 20, y'all gonna have to help me on that. 280. How many boys are there? Now, some of you, I want to ask you this. We create equivalent ratios because, you remember yesterday with the soccer team how 5 players wasn't enough? Well, think about for a whole grade. In the beginning, they said it was only 14 in the whole grade. Does that really make sense? Now, we created an equivalency, but now what are they saying is the whole grade? 280. For us here at West Lincoln, does that make sense for us? Now, if you go to a larger school, that is the real deal, okay? So I know that might not have made sense to you why there would be 160 boys in one class, but at bigger schools, that's how it is, okay? Where here, we only got 4. All right, we got 40 total. All right, here we go. So now we are done with that. What I need you to do is get to exercise 2 on your next page. I need you to get to exercise 2 on your next page. You're looking for lesson 3. Do you see lesson 3? Okay, so if you're looking for lesson 3, I need you to find this next problem and go ahead and read it. So look at the board and make sure you are starting to read this problem. Get it? Got it? Oh yes, homework. Right on there, 6 and 8 as well. So you'll be doing, let me go back and write it so y'all know. What do y'all tell me when I make a mistake? So also, homework, go back to where you wrote homework was 2 through what? 4, and you already have that written, and then it's going to be 6 and 8. Okay, and you'll have time to do it in class today, okay? So don't get overwhelmed. Did everybody end up having the next sheet? All right. So you are looking here on exercise what? 2. You are looking here on exercise what? 2. And we're going to do just like yesterday. We are going to do just like yesterday. Are we going to be doing every single one of these problems? Are we going to be doing every one of these problems? No. Okay? The ones we leave blank, that is not homework. That will be what? Practice. Extra practice. Okay? Because we always need extra practice, especially when this is something new to you. And if you need help with that extra practice, I know I've already said it, but the morning times, wind time, at the evening, before we leave, but check with Ms. Reno, okay, before you leave her classroom. You can come ask me for help on these few problems on extra practice if you need it. It's optional. Get it? Got it?
Yes, ma'am.
Now, you're going to see tape diagram everywhere. If you see tape diagram, we are going to write table. Because table is past and efficient. Okay? So we are going to write what? Table. So I do.
You do.
So if you see I marked out tape diagram, you need to be picking up your pencil. You need to be writing table. Get it? Got it?
Okay.
And if you see me forget one, let me know and say, Miss Jones, you forgot to mark out the tape diagram. On the ones that we do. On the ones that we what? So if you're doing that extra practice and it has it as a tape diagram, just know that you need to write it as a what? Table. Get it? Got it?
Good.
All right, here we go. Shawnee and Mel are using ribbon to decorate a project in their art class. The ratio of the length of Shawnee's ribbon to the length of Mel's ribbon is 7:3. Draw a table to represent this ratio. So we're just going back from the beginning to review everything that we just learned, okay? So here we go. Who's my categories?
Mel.
Shawnee and who?
Mel.
Mel. And what are they doing? They're cutting some ribbon, right?
Yes, ma'am.
Okay. What was Shawnee's to Mel ribbon?
7.
7 to 3. Could we have a total here?
Yes.
Yes, the total amount of ribbon that they used would be what?
10.
10. Did they ask you to do anything else? Have they asked you to do anything else? No. We're just practicing from the beginning because in reality, when you're learning something new, do you only need to hear one time? Nope. And I know it's going to get a little bit boring, but we're going to hear it over and over. Okay? So we know what to expect. Now, I want you to get to exercise 3. Now, I want you to get to exercise 3. It's on that same page, but at the top. It's on that same page, but up at the what? Top. So now, we're going to do the same thing, but this is a different problem. We're going to do the same thing, but this is a different what? Problem. When I'm creating these, you are only going to create one table. You're only going to create one what?
Table.
And it's going to be on A. Uh-oh. It's going to be under letter what? A, because y'all have a lot of room there. Okay? So I'm going to go ahead and let you. Oh my goodness gracious. I keep on hitting the wrong button. What do y'all tell me?
Push the
Still
eye.
full.
Put the eyeball there and tell me I'm still what?
Full.
OMG. There we go. Now I'm going to have my life together. Probably not, but we're going to try. What's today? Wednesday? We can do this. Are we making it? We can do this Wednesday. We got this Wednesday. What did I say last week? We can survive. We got this Wednesday. All right, here we go. So under A, we are going to have a table, okay? And we are going to keep on coming back to this table for letter A, B, and C. Okay, does that make sense? Now, go ahead and read your story up at the top. Read that ratio relationship up at the top. And then read letter A. Do you need to do anything else? Are you working it out? No, I just want you to read it. So give me a thumbs up once you have it written. Give me a thumbs up once you have it not written. Read. This is on video. You hear the those poor people having to watch this video. It's the real world. Welcome to it. You would think after videoing so much last year and the year before that I wouldn't get nervous in these videos. Yeah, absolutely. Okay, it says Mason and Laney ran laps to train for a long distance running team. when you at the end of this year, you'll get to try out for cross country. That's our long distance running team. Okay, focus. Sorry. So let me start over. Squirrel. Anyway, Mason and Laney ran laps to train for the long distance running team. The ratio, the number of laps Mason ran to the number of laps Laney ran was 2 to 3. So here we're talking about Mason to what? Laney. And what is Mason to Laney's ratio? 2 to 3. That's what I know. Put that down. There's also a little bit more that I could add to this table, just knowing Mason and Laney's ratio. What could I add to that table? I could add another column for what? Total. Did they ask about it? Nope, that's something you just have to understand. And what would their total be?
5.
Good, 5. If you put 6 there, you're still cool. Remember, part, we add to get the total. 2 plus 3 is 5. So all I did was read the beginning story from the very what? Beginning, right? Have I even got to letter A's question? No. If Mason ran 4 miles, some of you are like, Mason didn't run 4 miles. It said he ran 2. What are they doing? They're creating an equivalent ratio. Mason ran what? 4 miles. How far did Laney run? What do I need to do? Okay, it's either multiply or divide. Do we know yet? Nope. Let's look at our numbers. We go from little to, so we are going to, but if you don't know what's 2 times what equals 4, it's okay. If you don't know 2 times what equals 4, put it in your calculator. 4 divided by 2 is 2. So 2 times 2 is 4, and if I do it to that column, I have to do it to every single one. So 3 times 2 is 5 times 2 is
10.
So now that I know that, I can answer my question. How far did Laney run? 6. And what was the story talking about at the beginning? What are they running? Laps. And we can circle it. Now, are you going to have to draw out a whole nother table? Now, if you've got your table, I'm just borrowing yours. You're not wrong. I'm just going to borrow yours. If you make your table big, you can extend it out down here, okay? So if you did make your table pretty big, it's okay if it covers up the words, okay? Y'all hear me? So don't start erasing and freaking out. You can extend out your what? Table. You can extend out your what? Table. So let's go to letter B. Let's go to letter B. We're still talking about Mason and Laney. We're still talking about what? Now, I'm only erasing because we're now on a different what? Problem, right? Am I erasing my table? Should you be erasing your table? Okay, I'm just making sure. Awesome. So if it says tape diagram, what do we need to write? Uh-oh, I did the wrong one. Woo! Pencil. Here we go. Thank you. Good job, sir. All right. I'm going to extend out my what? Table. Because obviously we're on a different problem. If Laney ran 930 meters, oh man, this number just got bigger. I'm going to freak out. No, you're not. No, you're what? Where do you think automatically? I hadn't even read the whole thing. If Laney ran 930 meters, what could I do with 930? Okay, hold on. Put it where? Under Laney. So it will go under 3, 6, and here's 930. It says, how far did Mason run? Am I going to freak out? No. Look at this. Go back to the top. You could look at the middle, but go back to the what? the beginning ratio. Go back to the, take it to the, again, take it to the,
Top.
look at that beginning ratio. I'm going to ask myself, how did they go from 3 to 930? How did they go from little to big? What are we going to do?
3 divided by 1.
Okay, but what are we going to do to go from little to big? We would multiply, right? But when we get bigger numbers, can you do that in your head? No. So what do you have to figure out to multiply by? We do have to divide. What are we going to put in first? Because that's what it's got to equal as my whole. 930 divided by 3. So put it in your calculator to double check. I'm glad you know. 930 divided by 3.
315.
Okay, double check. Y'all got it? 310. I know it's getting kind of messy, but do you see 3 times 310 is 930? If I did it from my top to my third row, I have to do it to every top to the third row. So now what am I going to multiply 310 by? 2. 2 times 310. 6.
620.
Y'all put it in the calculator to double check. You're probably right, but I want to see those calculators. Okay, good job. All right, am I done? Oh, what do I need to multiply now? 5 times 300, what? 10. So 5 times 310, what do we get? 1,000.
550.
What did they only ask about though? How far did Mason run? And how far did Mason run? 620. And now are we talking about laps anymore? Lord help him if he had to run that. No, now what are we talking about? Meters. Does that make sense? Okay. Now, letter C is all we're going to do is look back at our table. Are we adding to the table? We're looking back at our table. So letter C, I want y'all to read it to yourself and give me a thumbs up. Read it to yourself and give me a thumbs up. Once you have letter C. Okay, what ratios can we say are equivalent to 2 to 3? So look at my table. What is in line with 2 to 3?
4 to 6.
What else?
620 and 930.
You see why tables are going to be your best friend, because we got down to part C, and if you didn't have that word there, you would have to start creating more equivalent what? Fractions. And another word for that is equivalent ratios. And we already have it there on our table. Okay. This time, did they ask us anything about the total? No. But we are going to still do it, because when they do, that makes it a level 3 problem. And they will ask it. Okay? So now, I need you to get to exercise 4. I need you to get to exercise 4, and that is on the back of that paper. Now, this is another one of those that we're gonna just have one table and we're gonna keep on adding to it. We're gonna have one what? Table, and we're gonna keep on adding to it. Now, if you look at my screen, I have everything for exercise 4 all on one. Is yours cramped like that? No. Okay? It's all on one paper for you. Okay? So I'm going to come over here, and I know I'm going to probably end up making a table. I don't know what type yet, but I am just going to go ahead and put a basic T up there for table. I might have to add a column in a minute. Okay? I just don't know what we're doing yet. So it says, Josie took a long multiple choice end of the year vocabulary test. Have y'all ever had to do that before? Take a long multiple choice test at the end of the year? Yeah. Yeah. You had to do 3 of them last year, didn't you? Okay. The ratio of the number of problems Josie got incorrect to the number of problems she got correct was 2 to... Can I go ahead and put something on my table based off of that story? My categories are incorrect to correct. So I'm going to put on my table I, C, and then a C. Did it? Got it?
Yes.
And you can put that under letter what? A. So go ahead and draw that table under letter A. Now, if I'm talking about a test, and I have incorrect and I have correct, is that telling me everything I need to know about that test? No, that's just telling me the parts that you got incorrect and the parts you got correct. The parts you got wrong, the parts you got right. Is that telling me what's that other category going to be? Total. Is it telling me my total? Nope, it's not. So I need to create another category. What do I know about incorrect? How many is it worth? And then how much is correct worth? So what do you mean that total on that test is going to be? Does everybody understand that? So I hadn't even started A, B, C, D, E, and F. I hadn't even started that. But when I'm looking at it, I have my table set up so I can make it make sense. I can make it make sense. Does everybody have that table set up under A? So, A says, if Josie missed 8 questions, how many did she get correct? If she said that she missed 8 questions, where am I going to go put that 8 on that table? Where am I going to put that 8 on that table? If she missed, what's another word for miss? Incorrect. So I'm going to put it under there. And it said, how many did she get correct? And I know it says draw a tape diagram, but are we drawing a tape diagram? Nope, we're drawing a table. Get it? Got it? So how did they go from 2 to 8? Multiply by 4. Well, if 2 times 4 is 8, I got to do it to all of them. 9 times 4 is, and then 11 times 4 is, so if Josie missed 8, how many did she get correct? So look under C, and how many did she get correct? 36. Correct. Does this table make it easier to find out your answer? Good. Now letter B. We're just going to extend out your table. If you made it too big, it's okay if you pass up the words on letter B, okay? It's okay if you pass up the words on letter B. Just extend out your what? Extend out your what? Table. Letter B says if Josie missed 20 questions, how many did she get correct? If Josie missed 20, another word for miss is wrong or incorrect. It wants to know now, how many did she get correct? Y'all ready? How do you go from 2 to 20? Times what? That one's always easy to see. Well, if I do 2 times 10 is 20 to that column, I need to do it to every column. 9 times 10 is 90. 11 times 10 is. So how many did she get correct on this one? 90. Correct. So what ratios could we say is equivalent to 2 to 9? What was our first ratio when we changed it? 8 to 36. And then 20 to 90. Do you understand where I got these ratios from? I look back at my table. It says come up with one more possible ratio of the number Josie got incorrect to the number she got correct. Now remember, she took a long end of the year test. She took a long end of the year test, and in the beginning is 11 questions total, a long test. 44 is actually about medium size for y'all, huh? Now we're up to 100 what? 10. Should I go past that? No. So let's pick a number to multiply by. Let's pick a number to multiply by that doesn't pass 10. But it stays kind of big. So I need to stay in between 4 and 10. Pick a number. Anybody? I hear 5. I hear 6. I hear 9. Raise your hand if you want to choose 5. Raise your hand if you want to choose 9. All right, we'll do 9. So 2 times 9 is 18. Well, that would be 18 incorrect. Oh man, that sounds like a lot incorrect, huh? All right, but let's find out how many she got correct. Do I do 2 times 9 again?
No, ma'am.
9 times 9 is
81.
81. And then my total will be 11 times 9 is
99.
still a pretty big what? Test, huh? So did we create another equivalent ratio?
Yes, ma'am.
What was that equivalent ratio that's equivalent to 8 to 36 and 20 to 9?
18 and 81.
18 to.
81.
Now, could I write these a different way?
Yes, ma'am.
I could write them as a fraction or with the word 2. So how did we find our numbers, guys? What did we constantly do?
Multiplication.
We multiplied. Okay? So how did we find these numbers? We multiplied. Did we ever have to divide this time?
No, ma'am.
And how we could go into detail with this a little bit more is we multiplied by the constant, not number, but constant numbers. And those constant numbers, and I'm going to abbreviate because we want to be fast and efficient in math. The first constant number was to multiply by 4. The next constant number was to multiply by,
10.
and then our next constant number that we multiplied by was 9. Okay, so how did we find these numbers? We multiplied our constant numbers. Now, we are not going to have to describe or create equivalent ratios because E and F is basically describing the same thing. Equivalent ratios you can multiply or divide by constant numbers. E and F are the same thing, but instead of just saying multiply, did we ever divide on that table?
No, ma'am.
No. F, you multiply or divide by constant numbers. So if you don't know that, I would suggest you write it down. I'm not writing it down. But on F, on letter
L.
F, describe how to create equivalent ratios. You multiply/divide by constant numbers. And that's all we're going to do on lesson 3. And we're just going to do a little bit more. I know y'all are over it, but we're going to do just a little bit more. We're probably only going to be about 5 more minutes. Got it?
Yes.
I need you to find lesson 4. I need you to find what? Lesson 4. And we are still talking about equivalent ratios and how to find the missing values of equivalent ratios. So the work that we don't do, guys, that is extra practice. And if it asks you to do a tape diagram, we're not doing a tape diagram. We will be doing a ratio what? Table. And I believe here we're gonna find out what it wants us to do. So exercise 1, it says decide whether or not each of the following pairs of ratios is equivalent. We're trying to find out if they're equivalent. Remember, equivalent fractions, equivalent ratios, they have to multiply or divide by the same what? Number. Okay? So if the ratios are not equivalent, find a ratio that is equivalent. And if the ratios are equivalent, identify the C. And what they mean by the non-zero number, what they mean by C is identify the constant number. That's all they mean by that. They like to get all, technical and give you terminology that you don't know. What they mean by non-zero is it means it cannot be what? It cannot be, non-zero means it cannot be 0. So they're talking about a constant number. And they say that you have to use to what? Multiply. So should we be dividing at all? Could you later on? But today, right now, are we going to worry about dividing? Okay. What could I do with these ratios? Real quick. Put them on a ratio table. 6 to 11 and 42 to 88. Does everybody understand what I just did? Do we know the categories? No. So I just put it like that. I need to find out if they are equivalent and they have to multiply by the same number. And it says multiply. So we multiply by the same number on each side. Raise your hand when you know if they multiply by the same number on each side. If you don't know, you'll be putting 42 divided by 6 in your calculator to find out what they multiply by, and then you'll be putting in 88 divided by 11 to figure out what they multiply by. So raise your hand once you know what they're multiplying by on each side. So what do they multiply by on this left side? 7. 6 times 7 is 40. What do they multiply on the other side? 8. Was it equivalent? No. So I give it a check mark. What could have been an equivalent ratio? What that means is we need to correct it. If they multiplied by 7 on the left side, what do you think we need to multiply by on the right?
6.
So mark it out like that. Don't erase it. And we're going to multiply by what?
7.
And then not only do I have to multiply by 7, and I have already corrected it, have I corrected everything? No. What do I need to mark out? 88. And what do you think is going to go there?
7.
Now, So what were the equivalence ratios? What would they have been? It would have been 6 to 11. So 6 to 11 and what? 42 to what? 77. Does that make sense? We're going to do it again. We're going to do it and I'm going to let you know it's going to try to trick question you. It's going to try to what? It's going to try to be a trick question. Okay? My ratios are 0 to what? 5 and 0 to what? What could they possibly multiply by on each side? Could it be the same number? What do we know about the rule about 0?
And always a 0.
It doesn't matter what number you multiply by. It can be 0 times 1. What are you going to get? 0 times 2. 0 times 3. So we might want to see what they did on the right side. What they do on that right side? Times 4. Could you use 4 on the other side? Yeah. 0 times 4 is 0. If you said 0 times 0 is 0, are you right? But could we have used 4? So, are these ratios equivalent? Yes. And what was our C? Our C is, another word for C is, our constant number is, what was the number that we multiplied by? Our constant number is 4. Was that hard? Our last problem for the day. Our last problem for the day is on the very back. The very back of the whole paper. Our last problem for the day. Get it? Got it? And once we get done with this, we're going to go to the restroom and get started on homework. Cool? Cool? Awesome. It says in a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is what? 5 to what?
6.
Good. Determine the number of walnuts that are in the bag if there are 54 cashews. How many of you are getting overwhelmed just by those first 2 sentences? What should I have done once I realized it was a ratio? Draw out A,
Table.
and then take one sentence at A. So go ahead and draw out our table and we'll finish it. We're going to read it and then we're going to draw it. And that's what we're doing. Read each sentence and then draw it. So let me start over so I don't get overwhelmed. In a bag of mixed walnuts and cashews, the ratio of the number of walnuts, first category, to cashews. So walnuts to cashews is 5 to 6. Okay? So, and it says it was in a bag. That's talking about our total, correct? What would that be? 11. I got that from the first sentence. Does everybody understand why I wrote down that? The next thing I'm going to write is determine the number of walnuts that are in the bag if there's 54 cashews. So where am I going to go put 54 under? Under cashews. Do this by yourself. Do this by yourself. Fill in the unknown boxes. Fill in the unknown boxes in your table. What is my next step? Don't tell me the answers for the boxes. What is my next step to do?
Multiply all the others by.
I agree. But why do I have to multiply? I go from little to big. And when you go from little to big, you multiply. So they multiplied by 9. That is my constant number. Okay? And if I multiply 9 to that column, then I got to do it to my other columns. And 5 times 9 is 45. And 11 times 9 would be, I filled in everything. So I'm prepared for what kind of question they're going to ask. Well, here it says use a tape diagram. Well, guess what? We ain't using a tape diagram. We used a table to support your work. Did we use a table to support our work? When you use a table, not only do you support your work, you also justify your answer. So do I need to draw out any more work? No, I just need to answer the question. It says justify your answer by showing that the new ratio created, the number of walnuts to the number of cashews, is equivalent to 5 to 6. Does this justify? So all I need to write down is what ratios are equivalent. So it was 5 to 6 is equivalent to 45 to 54. And guys, that's the best thing about using a ratio table, because it justifies your work. So if you're ever asked to show your work, it's going to be looking for a ratio table, and it helps you understand what you don't know. Now, the only thing that I want to add here is to make sure you understand that if I ask you, if I ask you what's the constant number, just the number was 9. But what happened to 9? What did we do to 9? We multiplied. Sometimes it might be not multiplying, dividing. Okay? And it matters on if that's that little to big or big to small. And that is our lesson today. Our lesson today was 2 ratios, A, B, and C, D are equivalent ratios if the positive number C. What did C stand for? Our constant number. And it says they're equivalent because 2 ratios are equivalent if both values are equal. If they use that same constant number. And ratios are equivalent if there is a positive number that can be multiplied by both quantities. And it's just going into detail about that constant number. But I want to make sure you understand that we are going to draw a ratio table every single time. And I know you haven't had a problem yet ask about the what? You haven't had a problem yet that asked about the total. But you will have one coming up, and you are prepared for it because we have been making tables with what? With a total, right? We've been making tables with a total. So just a reminder, your homework tonight will be 2, 3, and 4. And 6 and 8. Get it? Got it? Don't forget to make those ratio tables. Everybody please say bye.